Should science and mathematics be taught in a cross-curricular way? This video presentation aims to define cross-curricular work, look at the history of reports and curriculums that supported and criticised cross-curricular work. It will also look at the pedagogical and organisational decisions that affect cross-curricular teaching and learning and the advantages and disadvantages of cross-curricular work, as well as the maths and science links. Furthermore, this presentation will also look at how ICT can benefit and challenge science lessons, and conclude the points made. Cross-curricular work is when subjects are combined to make links on a certain topic so children can apply skills and concepts learned from one subject and transfer to another subject. The issue of cross-curricular work in the primary curriculum has been largely debated for some time and has been brought up in the press about using this child-centered approach or teaching subjects discretely. In the past, cross-curricular work has been associated with more child-centered constructivist approaches promoted by the Haddo Report in 1931 and the Plowden Report in 1967. This statement from the Plowden Report is used to support cross-curricular themes. However, the Plowden Report did argue that some subjects being taught discretely will be more relevant for older primary children. The increased prominence on teaching discrete subjects were encouraged by governments after the Three Wise Men Report by Alexander Rose and Woodhead in 1992, whereby they blamed superficial learning on poorly planned topic work. Between 1997 and 2007, a 10-year study was conducted by Boyle and Bragg, where they found that subjects were being taught in a cross-curricular way, and after the introduction of the numeracy and literacy strategies, there was a higher support for subjects being taught as discrete subjects. There are several reports that support working in a cross-curricular way as it has many advantages. In 2002, Ofsted recognised that schools that endorsed cross-curricular teaching and learning were often successful primary schools. Successful schools are ones in which teachers have the capabilities to plan opportunities for children to use knowledge and skills learned in one subject and apply it to other subjects. Kerry argues that cross-curricular works help children to develop thinking skills like problem solving and reasoning as they are applying knowledge and skills learned in one subject to another and synthesizing information and ideas from different sources, a view also held by Barnes. By developing skills to problem solve using cross-curricular topics, it can be beneficial to children in their future careers. Another advantage is that it increases children's motivation and engagement to learn, as learning is promoted in an interesting and relevant context to the learner because of the breadth of study. It is motivating to the children as it allows children to be independent and explore their own topic. Some disadvantages that have been highlighted are that cross-curricular work requires professional development of teachers, and in order to do this, time needs to be allocated. The Royal Society for the Arts highlighted that often teachers have received little training in designing the curriculum, so effective links aren't made between subjects. Some teachers may not have experience of teaching and learning in a cross-curricular way, and so this can affect the way in which they promote cross-curricular learning effectively, which is a disadvantage. Another disadvantage is that it is difficult when planning cross-curricular work to keep an appropriate balance between subjects, so it is important to have a clear rationale to linking certain subjects into the theme. Travis identified that there is a risk that one subject may have a higher status because the children may display more enthusiasm for one subject. Two subjects that can link together in many topics is mathematics and science. On the one hand, science and maths should be used in a cross-curricular way as a constructivist view of learning supported by the theorist Piaget states that learning is an active mental process where connections are made between prior knowledge, experiences and new concepts. Research done by the Space Project in 1990 to 95 shows that effective learning in science is produced when children can see the relevance of using scientific ideas and skills and when it is meaningful to them. The topic of measurement links appropriately to scientific investigation. Measuring begins in the foundation stage, for example looking at height or length of themselves, plants, paths or puddles at different times of the days. This measuring can be done in non-standard units such as bricks, feet or hands, and is the first step to accurate measurement. This is why topics in mathematics should be linked to science. Another reason is that the STEM initiative actually recognizes and promotes science, technology, engineering and mathematics as playing a huge role in education, and it is important that pupils understand how the subjects are interrelated. Engineering draws on aspects of both science and mathematics, which is why links need to be made between the two subjects for future use in engineering and technology. Another reason it should be used in a cross-curricular way is that combining mathematical and scientific skills and reasoning can help develop language, such as scientific vocabulary for all students, not just those with English as an additional language. This can be done through practical experiences. It can also produce vocabulary of early science and encourages scientific questions to be devised. In the maths curriculum, children are expected to learn the skills to measure length, weight and capacity using suitable equipment. For example, when teaching capacity, this involves using measuring cylinders. Often, children miss the actual understanding of what capacity represents. Without the practical experiences of measuring capacity, children will have little understanding of what 1 litre represents. A recent work that was carried out with 11-year-olds found that although the children understood capacity was measured in litres, there was no understanding as to whether you would measure medicine using milliliters or liters. This was due to children not receiving enough practical experiences. Therefore, by gaining an understanding of what a millimeter or liter represents, it can help when doing science investigations. During investigations, measuring time is a good concept to learn as it helps to support counting and understanding number strands. For example, in an experiment when measuring the time it takes for parachutes of different sizes to land on the ground, children will often use stopwatches to measure the time in 1/100 of a second. The results can be recorded in a table like this in order to clearly show the relationship between the size of the parachute and the time it took to land on the ground. From this, a conclusion can be drawn about how size affects time. Another advantage is that in a science context, knowledge gained in investigations can be used in real-life situations. Barr stated that motivation for learning is increased when students are given opportunities to work on real problems, which can be done through cross-curricular work. When pupils are involved in planning their learning and to make independent choices, they are more motivated. There are some debates as to why maths and science should not be taught cross-curricular way and should be kept as discrete teaching subjects, such as one reason being that poor planning leads to superficial and fragmented learning in certain topics because teachers are too ambitious when planning certain topics. Making links between too many subject areas in a limited amount of time to work leads to fragmented learning. Another reason why it should be kept as discrete teaching subject is because one subject could have a higher status over another subject. There could be danger that there is more emphasis placed on mathematics than on science when in fact it is a science lesson being taught, so children lose the relevance of the lesson. Linking maths and science in a cross-curricular way can be challenging as there are time constraints when planning for a topic, as time needs to be allocated to explore the links between the two subjects. Planning takes up a lot of time, especially when planning for a new topic, because physical and human resources may not be readily available at a school. Assessment is another challenge identified for developing cross-curricular approaches, as studies by Venel et al. And Rennie et al. Stated that there are difficulties in assessing children's learning and progress when using a cross-curricular approach, as opposed to when subjects are being taught discretely. Traditional forms of assessment are limited as the focus is mainly on assessing subject-specific knowledge, skills and concepts, and do not take into account how children actually apply subject-specific knowledge. Information technology has become important in science as it can assist scientists in gathering, storing and communicating information. Scientific equipment can be controlled by computers. Information can be stored and retrieved instantly and handled quickly, with the added benefit of data being transferred from one program to another in an instant. Presentations in the form of graphs, text, numbers can be selected and created in seconds. It is a helpful tool used in science by teachers and children. Examples of children using ICT in science can be by controlling a simple programmable toy or to create tables using a program called Microsoft Excel, which in turn can produce graphs. However, there are some disadvantages posed by using IT in school science. One is that children can lose the value of manually producing tables and graphs by hand on paper, and these skills may not be developed. Another disadvantage is that IT is a rapidly changing area, so there is a constant need for teachers to adapt and learn new skills. A further disadvantage is that having access to computers or computers being readily available can be a challenge and needs to be considered. In conclusion, maths and science should be taught in a cross-curricular way as many topics and themes fit appropriately to these two subjects. Without linking maths and science, engineering and technology would not be prevalent. There are several benefits to linking maths and science in a cross-curricular way, such as children being given the opportunity to apply knowledge and skills learned in one subject to another subject. It can motivate children to learn and interest learners, which in turn reduces disruptive behaviour. However, certain challenges have been highlighted in the sense that maths could have a higher status than science when being taught a science lesson. In order to get around these, it is recommended to have clear learning objectives to establish cross-curricular links with focus on learning and not just the activity, using the National Programme of Study to help with planning cross-curricular work. It is a good strategy to ensure appropriate balance between subjects. This will in turn help address the issue of a lack of progress made in children's learning, an issue raised in the Three Wise Men report.